Okay, let's look at the ones we already proved. We already proved for arc sine, arc cosine, and arctangent. Notice the only difference here is they're using u's, so they're doing the chain rule. If you notice, the only difference between arc sine and arc cosine is a negative. Remember, derivatives of cosines or co-functions are negative, so you have your negative, negative, negative on your co-functions. Otherwise, they're the exact same, so that's kind of nice. So it's u prime over 1 minus u squared, u prime over 1 minus u squared, right, the square root of. The only difference is it's negative for the co-functions. Arctangent is u prime over 1 plus u squared. Arc cotangent is negative u prime over 1 plus u squared. The ones that mess you up a little bit is for secant and cosecant, you need this absolute value of u on the bottom. So be careful with that, and it's the square root of u squared minus 1. So again, these are certainly three that I would expect you to know. I'm not going to lie, really the ones that you need to know are the arc sine and the arctangent. Those are really the important ones that you need to know. Okay? Because if you know arc sine and you know arctangent, that automatically gives you the next two, because the only difference with them, with the co-functions, is that it's a negative. So if you know those two, you really know those four. And then me as a teacher, even in Calc 2, I've never expected someone to memorize the one for arc secant or arc cosecant. I do expect them to have an idea of it. If you see that absolute value in the bottom, you should be thinking about arc secant if it's in that form, or arc cosecant in that form. But still, I don't expect them to memorize it, and I seldom, very rarely have ever tested on it. So the top four are the ones that I really care about. All right, so now that we've proven them, and again, remember, I could ask you to prove it on the test. Let's see if we could go ahead and do this. So what's the derivative of arc sine? The derivative of arc sine of 2x would be equal to 1 over the square root of 1 minus whatever's on the inside, which is 2x quantity squared. But then you need to remember chain rule to multiply by the derivative of the inside. Well, the derivative of the inside is simply 2. And 2x quantity squared would be 2 squared, which would be 4, x squared, which would be x squared. So what am I ending up with when I simplify this? A 2 on top, square root of 1 minus 4x squared on bottom. Okay, let's move on to the next one. How about arctangent of 3x? The formula for arctangent of 3x, or arctangent of x, is 1 over 1 plus u squared times u prime. We actually did it as u squared plus 1, but the order doesn't really matter. Don't worry about that. So this is going to be equal to 1 over 1 plus whatever you see on the inside squared times the derivative of the inside. Well, the derivative of 3x is just 3, and 3x squared would really be 9x squared. So it looks like I'm getting, what, 3 over 1 plus 9x squared? Go ahead and write that in your answer blank. Okay, let's move on. How about arc sine of the square root of x? Well, again, anytime arc sine of anything, the derivative is going to be equal to 1 over the square root of 1 minus whatever's on the inside, which is the square root of x squared. But then always remember, you have to multiply times the derivative of the inside. Well, let's think about this. Square root of x squared is an x, and the derivative of the square root of x, that's x to the 1/2, so that'd be 1/2 x to the negative 1/2, which is 1 over 2 root x. So what happens when we put that together? Well, I see a 1 over the square root of 1 minus x times 1 over 2 root x. I guess we could do some simplification. So this would be 1 over 2 times, and we can actually, because they're both square roots, we can actually distribute that x into both of those terms. So that would be using multiplication, right? Only because they're both square roots. So x times 1 is x, minus x times x would be an x squared. So I'm getting a final answer of 1 over 2 times the square root of x minus x squared on that problem. I'm not going to lie, if you left your answer in this form right here on the test, I would have given you full credit. Let's look at the next one. Man, they really emphasized arc sine. I don't know why they didn't try to do any arc cosines. But again, if you know arc sine, you know arc cosine. The only difference is a negative there, right? Okay, so here's arc sine of e to the 2x. So any derivative of arc sine, sorry, let me get black. Any derivative of arc sine is 1 over the square root of 1 minus whatever's on the inside, which would be e to the 2x quantity squared. But then you always need to multiply times the derivative of the inside. So e to the 2x squared, when you raise a power to a power, you just multiply it. So 2x times 2 would be e to the 4x on the inside there. And then what's the derivative of e to the 2x? Well, the derivative of e to the 2x is copy-paste e to the 2x, but then you need the derivative of 2x, right? So this is like a chain rule with a chain rule. Well, the derivative of 2x is just a 2. So a lot of pieces there. Let's put it all together. We have e to the 2x times 2, or 2e to the 2x on top. And on bottom, we have the square root of 1 minus e to the 4x. Okay. So that would be that answer to the problem right there. I do want to note that this is different than the problem in the textbook in that I probably had a typo, that this shouldn't have been arc sine, that should have been arc secant. So let me show you where I'm talking about. Right here, that shouldn't have been arc sine, that should have been arc secant to do the one that was in the textbook. That's okay though, we'll just stick with this one. I'm going to go with this answer. 2e to the 2x all over the square root of 1 minus e to the 4x. Perfectly fine right there.